has published articles in several big German magazines, computer magazines, and he's an expert in packet capture and analysis. Jesper will be talking today about the various issues that can arise when sanitizing and anonymizing packet captures and how to deal with them. So please help me welcome Jesper to this talk on sanitizing packet captures, fun and games until someone uses IP version 6 or TCP. Welcome.
Thank you. So welcome. I didn't expect so many people in this room because the F-Not News show is coming up soon. So if you're leaving in the middle of the talk, I'm not going to be disappointed. So just go ahead. Yeah, I'm Jasper. If you want to follow my stuff on Twitter, this is my handle. This talk is about sanitizing PCAPs, so packet captures. I do a lot of work reading packet captures, so you probably heard of the tool called Wireshark. I use it every day, and very often I have something that I want to show other people, but there's something in there that I can't let them know, like IP addresses and other stuff that may be sensitive. So I need to sanitize them, remove all the critical information so that nobody can see what my IP addresses are, what my MAC addresses are, because from the MAC addresses of you, which you probably know, you can deduct the vendor of the device quite often, not always, but in a lot of cases. So it may be important to do that before sharing stuff. Okay, so then first slide that I'm going to show you is going to surprise you because it has nothing to do with PCAPs. Once upon a time, I did something other than that. I worked on computer games, like this one. I didn't write it, but I did the German translation. And also that one. It's like 20 years ago. I came to remembering those times when writing the talk, because back then I had to do something that I hated when sanitizing PCAPs as well, and that is using a hex editor to edit stuff, because it's very complicated to get things right. Back then, in those times, when LucasArts and Westwood published those games, we didn't get any source code. Because you can imagine LucasArts back then was already very, well, they're not giving things to you that where they think you could do something with it, like compile their game again or something. So they only got us the binaries. So I had to patch the German translation into the English game. Most of you know that most sentences in German, if they are going to be nice, are much longer than the English ones. So we're sitting there in the room translating the game and overthinking like, oh damn, how I'm going to translate this. It needs to be not longer than the English phrase and still sound cool. And that is a big problem, so it cost a lot of nerve to do that. I can show you how that looked like, because I got the eye of the beholder binary here. And you can see here there are all the strings in there, in the executable, unobfuscated, which was quite, in these times it's quite surprising. Nobody uses plain text strings anymore, right? Back then there were, and so we were editing in this all the time, translating the game, and that is something that I never want to do again, but sometimes with PCAPs I had to do it again. And this is what the talk is about, how to get a solution to that kind of problem. These days now, if you're doing computer game translation, of course you get the resource files with all the translation strings in them and everything, so it's much easier, but back then that was really hard work. So, for those of you who don't know what a PCAP is a packet capture, meaning it's network packets that have been captured using a capture device. It can be a PC or something special. And it's a file format. It's a binary log, and that is something quite a number of people doesn't always recognize or understand, because a lot of times we get questions about how to read it with a text editor. Doesn't really work. You need to have something to read it, and most people, for this kind of thing, use Wireshark. PCAP is an old format. It's used a lot still because it's easy to write and easy to read. The much better one is PCAP-NG. I don't know if you've heard about it, but I can recommend it because you can do much more things with it, like putting comments into packets and stuff like that. But still, a lot of tools only can do PCAPs, so we have to still work with it. TCP-dump writes it, Wireshark writes it. Well, dumpcap is the tool that writes it, but Wireshark tells dumpcap to write the stuff, and snort and everything else. So, why sanitization? Yeah, first of all, it's quite similar for editing packets to be able to replay them, which is sometimes necessary to mess with them and play them back to the network and see how a device reacts to it. But it's a little bit different because your focus is not on changing the packets to test something, but to remove sensitive details like user credentials or network topology. You don't want somebody to know what the IP addresses are in your network and what the gateways are and what the MAC addresses are, stuff like this. Device and software version information, because as we all know, if you find a banner from a device that tells you this is Cisco router something whatever, everybody will Google, is there an exploit for this? And if there's one, you try to attack it, so it may be interesting to remove those. Vulnerable protocols, of course. If you have telnet in your network, I would consider that a vulnerable protocol. And of course, payloads. So if you have something that is sensitive in itself and it's transported over the network, maybe you want to remove it because you don't need it for the analysis or something that you're doing later, and then you can strip it. Okay, very often people do something like this. This is actually a screenshot that I have taken from one of the Wireshark Q&A sites. People post these kinds of screenshots of Wireshark and try to remove the sensitive stuff by painting over it. Sometimes it's really funny because you still have the hex decode down here, and then you can, if you can read hex, still see everything. So that's also a danger that you have when doing something like this. You may miss something that you need to sanitize, but you didn't, well, see that this is also the same information. Most people never look at the hex in Wireshark, so they don't realize that everything that is in the decode area is also in the hex area. In this one it isn't, so that's okay. And if I'm going to analyze something, somebody shows me a screenshot like this, very often my answer will be, first of all, nice, but I can't help you with it. Get me a PCAP. If you can't get me the PCAP because there's the IP addresses that you don't want me to see, sanitize them, replace them with something else. Okay? And this is what we're going to talk about. So there's two main groups of people that want to sanitize packet captures. That's first of all the network analysts, and a lot of them are, for example, guys working in a company. I had one occurrence where a firewall administrator told his boss, okay, this firewall company wants me to send them captures from what our firewall does so they can debug why it's not doing what it should do. And the boss said, well, we can't do that because there's sensitive information in this network. And they're at a kind of a deadlock, like the database, the firewall vendor says, I can't help you without the PCAPs. And the customer says, well, I can send you the PCAPs. So what do you do? Well, you could sanitize them and remove everything that you think is critical, and then hopefully not remove too much, because if you remove too much, the firewall vendor will say, well, with this I can't see what the problem is. So you're always trying to find the right balance between removing stuff so that nobody sees your IP addresses and whatever, but not so much that it is unusable. And sometimes I see people removing so much stuff that it's basically unusable. So you need to find the right amount of sanitization. As a network analyst, I often only need packets up to the TCP layer, because if things go wrong in a network these days, it's most of the time related to how TCP works and what it does. I can see timing issues, retransmissions, packet loss, whatever, and I don't need the payload for it. So removing all of this payload after the TCP header is no big deal. Because a lot of networks have these obscure middle boxes. I don't know if you have seen any of those. These can be things like packet shapers, firewalls, WAN accelerators, all these magic boxes that do funny things with TCP but don't get them quite right all the time. So in that case, you can lose everything above TCP, all the payloads, doesn't care, don't matter. So, and sometimes you still need stuff like FQDNs, so DNS names, things like this, or URLs, and then things get complicated, because then you're on top of TCP, so you're in the stuff that is transported over UDP or TCP, and replacing those can be a big nightmare, and I will talk more about why it can be a nightmare. Security analysts or researcher, they usually have other stuff they care about, because they don't care about Ethernet, ARP, IPv4, TCP, UDP. Not that much, at least. I mean, if you see like an ARP-based attack, yeah, well, okay, then sanitize the MAC addresses and you can still see the attack going, but from different MAC addresses, it doesn't matter. As you can also see here, I intentionally wrote IPv4, because nobody cares about IPv4 anymore, because it's quite stable by now. That doesn't really work for IPv6, because IPv6 is still in a stage where it does crazy things sometimes, and it may be interesting to see attacks that are based on IPv6, like extension header chains that you build. I don't know how many of you are using IPv6 already? Quite a few, okay. Not that many, it's say 10% maybe. There's a lot of things in IPv6 that is still problematic, so sometimes you need to see those. And of course, as malware analysts or security analysts, you often need stuff like the FQDNs, URLs, binary payloads, so you can't just remove them. So sometimes the kind of sanitization that you do is different if you're looking at it from a network analysis point of view or from a security researcher point of view. Okay, the challenge, as I already said, is don't remove too much to make it unusable, but remove as much as you need to not give away anything that you want to keep a secret. So you need to find the right amount of, well, replacement or removal, whatever. The second problem that we have is if there's only one packet that you need to change, that's quite simple. You can still do it in a hex editor if you have to, because, yeah, it's a lot of work, but it's just one packet. I put out a challenge like half a year ago or a couple of months ago at the Wireshark conference. The packets were in the range of, I don't know, a couple of million, and it was like a 2 gigabyte file. Editing those, because they were taking it to customer side, it was a real-world problem that I wanted to show as an exercise. So I had to sanitize 600,000 or more packets. And doing that with the hex editor, well, I would be editing to the end of my days probably, yeah? So trying to replace everything that I needed. So for that, you need something else. You can't just do it with an hex editor or something that works well for just one packet. And I will show you a couple of editors that you can use for one packet, but not so much for many. The protocol complexity is another challenge. Most of you have not yet worked or played with IPv6 that much, but IPv6 has a lot of dependencies that can really make things very difficult. I'm going to show you an example of how difficult it can get. And you maybe see, even if you don't know much about IPv6, that there is a lot of things that you need to look at to be able to replace stuff that it doesn't fall apart after sanitization, basically. You have protocol dependencies. Again, IPv6 or sometimes ARP and stuff like this depend on each other. So if you replace something in another protocol, you need to keep that replacement consistent in the next protocol. Again, something I will show in IPv6. And then there's something that a German university coined as a term, I think. It's called defensive transformation. Who's ever heard that, defensive transformation? It basically means if you're looking at a network packet and you find some kind of information that you don't know what it is for, drop it. Because you cannot keep it. If you keep it, it may expose something sensitive. So defensive transformation means when I look at the network packet, I try to understand everything in the packet, and everything that I don't understand, I will not write into the sanitized packet. So I will lose information. But it's better to lose information than to expose stuff that you don't want to be exposed, because very often in the end you will find out, oh, I still exposed the IP address because it was still in the hex dump, or something like this. So defensive transformation is a principle that you should, well, keep in place to avoid mistakes exposing stuff. Thank you. Okay, hex editors. I showed you a hex editor already, so I mean, replacing packet content in a hex editor is, well, it's quite a challenge. Even if you are able to, well, I have Bill Murray here because it's sort of like a Groundhog Day task if you do that on a lot of packets. It looks like this. You go on some packets, like maybe this one. I use 101 editor for this. So, well, you can go in here and start replacing stuff. But you need to calculate IP addresses into hex values all the time. That doesn't make any kind of sense, not for many IP addresses. You can use search and replace, of course, but very often you will miss stuff. And I want to show you something where you can easily miss stuff, and that is in, for example, the HTTP packet that I have here. If you're replacing by bytes, for example, in this GET request, you will see here IP addresses up here. They are 32-bit numbers, but the IP address of the X-forward4 here, that is ASCII text. So that is something completely different, but it's the same IP address. But one is 32 bits, the other one is much longer, obviously. We can also see that in the decode down here. The IP addresses are somewhere in here, and down here you will see the IP address as text. So you need to replace text and 32-bit numbers, and they need to be the same IP address. So you have to transform them all the time. This is really no fun at all, because it will also change the packet length if you do something like this. And if you change packet length, something really funny will happen. And I can show you that because I already did. You look at this trace there, it looks fine. You have a SYN at the beginning, a fin ACK at the end, no retransmissions, no packet loss, no warnings from Wireshark, nothing. And I did a replacement of the IP address in the X-forward4, and now the trace looks like this. You have a lot of red lines there. They're really small. I will make them bigger for you. It tells me previous segment not captured, unknown segment. So this is something where a network analyst will get kind of, something is wrong here. I have lost packets. There's something missing here. No, there isn't. The only problem, and you can see that up to this packet, everything is fine. The problem is that I replaced the IP address in here, which was 192.168, something longer than this, actually 7 characters longer, with something shorter, and that means that every sequence number in TCP following this packet will be 7 bytes too long. So Wireshark will all be like, I'm missing 7 bytes here. There are 7 bytes missing. There must be packet loss. And it goes through all the packets because every sequence number after the packet that is shorter or even longer will be off by the amount of bytes that you replace. So you need to then go into every packet and adjust every sequence number, but only after you did the replacement, not before. So you need to keep like a lookup table, like in which conversation did I replace, in what sequence number, how many bytes, and how much do I need to adjust this? And you can do multiple replacements in one conversation. So you have multiple points of, now I need to add 7, now I need to remove 14, now I need to add 25. It's really a nightmare. So this is why TCP very often can be hard to sanitize correctly if you're going into replacing stuff in the payload. This only happens if you're in the TCP payload. It doesn't happen if you change anything in the TCP header. Okay? All right, so this is how you do the manual replacement. There's also something in Wireshark that I don't think many people have seen. Who has used Wireshark before? Oh, most of you. Okay, good. You can do this. You can go into Wireshark. And this one is, I hope, the correct version. This is 2.1. Well, it's quite new. I use the legacy version. Legacy means it's GTK based, that's the old one. And in here you can go into Edit, Preferences, and down here there's a checkbox for Enable Packet Editor. And with that you can now go to any packet and say Edit Packet. And now I can go in here and, for example, change time to live and say, well, now it's 63. Okay. And instantly, of course, the checksum is wrong because I changed something, right? So if you're doing replacements in a packet, you always need to fix the checksum. Really always? Well, sometimes you have packets where the checksum is already bad in the original. So what do you do? Do you fix it in the fixed version? Hopefully not, because you kind of remove the symptom that the checksum was wrong from the packet. So you need to keep it bad if it was bad, but keep it correct or recalculate it if it was correct. So something else that you need to keep in mind, like, oh, was the checksum okay? Well, replace it. Stuff like this. Well, this is something you can do with Wireshark, but only in the GTK version, not the new Qt version. Okay, then the other thing we have is Wire Edit. Wire Edit is a relatively new tool. You can use it to, well, where's my desktop? Oh, it can only work with PCAP and CAP files. It doesn't know PCAP and G, so I need to save this as PCAP first. I should have kept an example in PCAP format, but I didn't. Test.pcap. This is just a file conversion, so don't worry, there it is. And now you can go in here and say, well, I want to edit the packet. Well, it's kind of confusing because you think you need to edit something here, but down here there's everything in that packet. And now you can say, well, I want to change the host and want to write in here www.packetfoo.com. Let's say I want to change it to blog.packetfoo.com. Okay. And the good thing about Wire Edit is it will automatically fix the checksum. So you don't have to worry about it. You can also add stuff, remove stuff, and you will run into the same problem with the sequence number. Okay, so that is Wire Edit. And again, if you do the manual stuff, you need to have Bill Murray on your side and stay in the time loop because it will take a lot of time to do this. Okay, if you do batch editing, which means you're looking at replacing stuff in an automated way to a lot of packets, to many packets, there's a couple of things that you need to keep in mind. Like if you replace an IP address with another IP address, you need to keep replacing the same original with the same replacement. Yeah, you cannot just replace it with anything you want. It needs to be consistent. And there's a couple of problems with that, because if you have a lot of IP addresses, you need sort of a database to store stuff, or you do a hash kind of thing, so that you hash the original and use the hash as an output for the new IP address. But very often that gives you funny IP addresses. So you can end up with 127.0.0.1 as the replacement when the original was 10 dot something else. And you're like, really? Someone's sending stuff from localhost? I don't think so. And then you look at the original, like, oh no. Okay, so these are all problems that you can run into. Bittwisty, TCP rewrite are basically command line tools that are used to prepare packets for re-injection into the network. So they're basically designed to help you modify packets for replay stuff. Yeah, so they're not sanitizing tools by trade, but you can use them, of course, also for kind of sanitization. Then there's Packet Anon. These are the guys with the defensive transformation. Then there's a new project. Basically, Packet Anon is a Linux tool that is using XML files to do automatic conversions on packets. It's also quite nice because you can pipe stuff from TCP dump directly into Packet Anon that will write never the original to disk, but only the sanitized stuff. That is kind of nice. And you can define how strong the replacement should be if you want to replace the MAC addresses, the IP addresses, and everything else. There's PCAP-lib, which from my point of view is not such a good name, because I don't know if you know this, libpcap is the library that reads and writes PCAP files. These guys are from China, they probably didn't realize. They wrote a paper on packet anonymization and used that kind of name. So if you want to take a look at it, they basically used the Wireshark sources to read and write packets in an automatic kind of way. So they have a nice project that hasn't continued since 2012, I think. So most packet sanitization things that you can find on the network are research papers. And as soon as people have turned in their research papers, the development stops, of course. So, well, it's out there, it's open source, go and use it and modify it, but it doesn't seem that many people do. Okay, and then there's the last one, which is called Trace Wrangler, and that is my tool. So I'm going to show it to you. It's a bit different because it doesn't run on Linux, except you use Wine because it's written in Delphi, which is, yeah, I know, not a great language. Only Russians use it, I'm told. So Trace Wrangler is for automated replacement of stuff. And I'm going to show you a little demo. What you can do here is, where is it? Up here. So you add a PCAP file, or let's say, it's this one. And then you add a anonymization task. And then you can tell it, well, what do you want replaced? And one of the most important ones is this one, telling it to remove everything that you don't recognize. So if Trace Wrangler doesn't know how a protocol works, please remove it completely. That way, everything usually after TCP will be dropped, because I cannot parse that many protocols yet that are above UDP or TCP, but I'm working on it. So I'm not a research paper guy, I'm continuing my work, so it will improve. You can also tell it to truncate after a certain layer or after a certain offset or replace some strings in here, but the more important things usually are replacing IP addresses. So you can replace by a list, telling it like, well, 192.168.0.1, replace it by 10.001, and it will do that for every IP that it finds, no matter where it is. If it's in an ARP packet or in an IP packet or in a payload, doesn't matter, it finds it, it will replace it. Or you can go in and say, well, replace subnets. Replace everything that is in 192.168.0.0/24 by 10.000/24. Which is good, because then all IP addresses from the original net will end up in a new net and not in completely different networks, because very often if you randomize stuff, everything will end up in different crazy networks. And you're like, why are these two IP addresses talking to each other? They're like, the one is in USA, the other one is in Germany. What are they doing with one hop between them or something? So that doesn't make any sense. It will do a lot of this also automatically. If you randomize IP addresses, it will keep multicast addresses multicast, because that's another problem. If you have a multicast address and you're randomizing it, it could end up like a loopback address or the zero address or a private address, which is not the same anymore. It's completely different then. APIPA, I don't know if many have heard that term, that is the automatic private IP addressing thingy. If you do DHCP but you don't get one, 169.254 something, everybody has seen those and cursed them. If you have something like this in a trace, it's quite interesting, because that means DHCP didn't work. So for analysts, you don't want to replace them. And on the other hand, they're like randomly generated anyway, so they then don't pose any kind of threat if you expose them. It doesn't make any sense to replace them normally, but if you want to, you can tell it to. And then documentation IP addresses are a special IP address range that is specifically for documentation, so replacing those doesn't make any sense again. Yeah? There's one for IPv4 too, not only IPv6. Yeah, but few people know this. Okay, and then there's something here that is called the private range mode, which means I told Trace Wrangler to, if you find an IP address that is 192 something or 10 something or 172 something, it's already private. Please keep it private, because I want to see in the end that it was private, and don't change it into a public IP by mistake, because then again I have something that it wasn't before. You can also go in and say, well, randomize it over the full address range, or do not randomize it at all and keep all the private IP addresses private, because it doesn't matter. Okay, similar things you can do for IPv6. For ICMP, you can decide which kind of packets you want to remove, if you choose to. Then there's ICMPv6, and that is quite interesting, and I'll show you a trace why IPv6 is such a big problem. 15, okay. This is the last demo, I think. If you take a look at this packet, which is IPv6, so if you haven't seen IPv6 before, now you do. This packet is kind of problematic, because if you know a bit about IPv6, the destination IP address here, FF02, ::1, and so on, is a very special multicast address that is created for a search. Kind of, I want to know where my neighbor is, which used to be ARP before. ARP doesn't exist anymore in IPv6, for those of you who don't know. So you use ICMPv6 for this. This IP address is based on that IP address. You can tell by looking at the last couple of bytes here, you see they are the same. So this one and that one, if you replace any of them, you need to keep the two of them consistent, but they're different classes. So that is a problem. Okay? And the other thing, which is even worse, and by spotting the FFFE in here, every IPv6 administrator will tell you this IP address was created from the MAC address. So look at the MAC address up there, and you will see it again, that this here, 026E A5, is somewhere up there on the, well, see, from there, yeah, the destination is kind of replaced here. It's like this. So you need to look at the IP address, the multicast address, and the MAC address, and if you replace any of them, replace all of them. So you need to change the MAC address, then the IP address, then the other IP address. And that is something that TraceRanger can do, but nobody else so far I've seen. Which is, it was something where I thought, this is easy, and then it was a weekend of coding. So it took a lot more time than I thought. Okay, and TraceRanger can even do work on crazy stuff like this. I don't know if you've ever seen a packet like this. Yay! Ethernet, MPLS, MPLS, Ethernet, IP, UDP, GTPU, which is a tunneling protocol, IP again, TCP. And if you want to sanitize this, good luck, because it's a lot of stuff. But I can read all of them in TraceRanger and do the sanitization for you, and it should work. If it doesn't, send me an email, I fix it. Okay? So, TraceRanger can be downloaded, and that's the last thing I'll show before going to questions, if there are any. It's downloadable here, if you want to. I didn't open source it yet, but I will. I'm still looking at the licenses. I'm getting crazy. I already asked you about it, like which one I'm going to use. Well, I'm going to use probably GPL or something. Then you can look at the TraceRanger code also. And, well, all of this I already did talking. And thanks and questions.
Great. Anyone with questions? There are 4 microphones in the room. You can go to the microphones now.
If not, send me an email later. That works too. Or Twitter or whatever. Yeah.
Yeah. There we go, right here.
You thought about the problem with HTTP, analyzing HTTP.
Could you get a little closer to the microphone, please?
Sure.
Yeah,
the problem with anonymizing HTTP,
yeah.
we have the IP also on layer 4
yeah.
or 5, 6. That's not something you can address with Packet Wrangler.
Not right now. No, I'm working on it. I wrote basically what TraceRanger does it reads the packet from Ethernet up to the highest level it can pass. Right now that stops at TCP. But I'm working on an HTTP parser already. And then it replaces everything that it finds and reconstructs the packets from top to bottom. So basically it pulls it apart, replaces everything, puts it back together. That's the only way that you can do this. And I've started working on the HTTP parser, and I tried to get it done for CCC, but I didn't because I didn't have enough time. It will be the next thing that I do, and then you can do it in Tracewangler. Yeah, it's a lot of work because there is the reassembly coming into play. Most of you know probably what TCP reassembly means. That means that you have to recombine all the payloads first, because an HTTP request can span across multiple packets. There are sometimes very long URLs that go from one packet over 4 or 5 more, and you need to reconstruct it first and then replace stuff, and things can get longer or shorter. Then you need to cut it into pieces again, but they need to be the same size, or they should be. So you need to remember where the cuts were. And what happens if you have packet loss and something's missing in the middle? Then it's like, uh-oh, there must be a retransmission somewhere, but where is it? I have to look here, get it here, put it in there, reconstruct it, put it back there when you write the file again. So I cannot even read and write stuff sequentially. I need to read it, try to put it together, and then remember where everything was before I read it, and write it out like in the same order that I read it. So that's why it's a nightmare, yeah, to work on TCP stuff. It's really not easy, because otherwise I would have done it already. I'm working on this tool for 3 years now, and I haven't got there yet. But I will, in some, well, far future, maybe. But I will do this for one packet stuff already. So most HTTP requests are in a single packet, unless they're very long. And that will be something that I will do in the next couple of weeks, probably.
Do we have any questions from the internet?
Yes, there was one question. Do you also anonymize domain names?
Right now, no, I don't. But I'm really close to this because I can already read DNS. But DNS is another big problem. I have one slide on this. If you're replacing FQDNs and you have something like testpacketfoo.com and you replace it with something secret.com, that means that you replaced packetfoo with secret, com with com, and test with something. And if you then have ABCDEF packetfoo.com, you need to remember that you replaced this with secret, but this here needs to be replaced with something else. So again, you need to remember parts of the FQDN, you need to pull it apart, put it back together. It takes a long time to get that right, and I haven't gotten there yet, but it's one of the next things I have to do, because for the HTTP thing to work, I need to be able to sanitize the host name in the GET request. So that means first I need to be able to sanitize FQDNs. That is the first step that I have to do, and then I can do the rest. So yeah, I will do that. I'm not there yet. Too much work at Airbus.
Thanks.
Thank you.
On the left side, right here.
Is there a command line interface?
Not right now. The problem with that is that if you look at the replacement parameters in Tracewangler, and you see it's a big dialog here, to add all these options as a command line version would make it very long, or you need some sort of a parameter file that you give into the program. I put a lot of code into the GUI version to be able to make sure that the user doesn't do anything crazy that will mess with my program. And that's why I don't have a command line version yet, because then I need to sanitize the input first. And that is a nightmare in its own, as everybody knows, right? So sanitizing inputs, not so much fun. Even less fun than writing a GUI, which is no fun at all.
Okay, next question. Right here.
With Wireshark, you usually try to find a problem, as you said, whatever, networking or whatever. And with Wireshark, we did a lot of work to actually get it bulletproof, to actually do the IP addressing and whatever correctly dissected. How often does it happen to you that you actually, introduce new problems into the capture file? And how easy or how hard it is to actually detect this?
Okay,
at the moment.
So if I get you right, you mean when I read a PCAP and write it again and do something wrong when writing it, how often do I put problems in there?
I mean, you're actually trying to troubleshoot something.
Yeah.
And you try to sanitize the PCAP, and then you send it to someone, and then he tried to analyze it.
Okay, and then he finds something that I introduced while sanitizing it.
Exactly.
Okay, yes, that is a problem. And there's something that I live in constant fear about, because if I insert problems into a capture file that hasn't been there before, I may lose reputation quite fast, because basically I'm more of a problem than helping you. So I try to make sure that this doesn't happen. One of the first things I usually do is, when I'm able to read and write package files, I don't sanitize them at all. I just read them, deconstruct them, and write them back out again. If that works, and if I get an identical copy, I'm relatively sure that I'm okay-ish. And then I need to do the replacement, and then there's a lot of checking if this is correct. The good thing is I'm doing packet analysis for over 10 years now, so I'm one of the most feared guys when it comes to Wireshark, because I very often am in contact with the core developers and giving them hell about how Wireshark is doing things wrong. I can spot stuff going wrong by looking at packets. And the first thing I always ask myself is Wireshark wrong or am I wrong? And very often, it's 50-50.
I'm going to ask the internet. Is there another question coming from the internet? No question from the internet. Okay, then we have one right over here. Thank you.
Yeah, it's been, I think, a decade since I looked at it, but do you know about Argus?
Yeah.
And randomize that stuff?
I haven't really used it, I have to admit. The thing is that Argus is, I think, I've seen it to be web-based from the front end kind of thing. I have to try to take a look at it, but I haven't used it yet.
Okay. It's I think it's mainly command line based, but it uses an own capture format and does a lot of analysis itself.
The problem with that would be, can you convert it to PCAP?
Yes.
Okay, then it is okay. Because what I don't like is somebody's writing an arbitrary protocol, nobody else can read, and then you want to give it away for somebody who only can read PCAP. So if you can do that, well, I have to take a look at it. I wanted to write a tool that is fully under my control, that I can tell to do everything I like, and do not do stuff that I don't like. So maybe I'm doing stuff that Argus already can do. I have to take a look at it, but thank you.
Okay, if there are no more questions, then as Jesper said, you can email him. But for now, please help me to thank Jesper. Thank you for the talk today.
Thank you.